So I'm going to have you start today with writing down, if it's bigger on the bottom, what's the rule for that? If it's bigger on the top, what's the rule for that? If it's the same on both, what's the rule for that? And these are for the horizontal asymptotes. Bigger on bottom would look like this. X over x to the third plus 3. That's bigger on the bottom. Bigger on the top. Or same on both. Noah, what's the rule for bigger on the bottoms?
0 plus whatever's outside.
Very good. And remember, it's y equals. Horizontals are the horizontals. All right. Gio, what's the rule for the bigger on tops?
If they're bigger on top, then they are the ratio?
Nope.
Instead, are they zeros?
This is the one where there aren't any. There's no buts. None. If it's bigger on top, there's no horizontal asymptotes. All right. And last but not least, raise your hand. What do you think?
The ratio of the same one.
Smarillo's right. It's the ratio. So what is it in this case?
Would be 1 over 1.
Yep. Those are the key numbers right there, the lead coefficients. So 1 over 1, which is 1. All right. Any questions about that? Yes?
Wouldn't y equals be vertical asymptote or?
Nope. The verticals are the zerticals. X equals are the verticals. That's why because I didn't even have to think about your question because I have memorized it as horizontal. The y's go with horizontal. Horizontal. Okay. All right. But it's good that you asked because you might have been that kid that you make probably 2 mistakes on the test that if you switch your x and y's around. All right, so I think I should give you a problem that's like that. So let's say you had x minus 3 and then an x up here. And then let's make this a 2x up there. And then let's make this x squared plus and I'm gonna pausing. So x squared plus 4x minus 21. There we go. You should be able to tell me about 17 things about this. The horizontals, the verticals, the x-intercepts, the y-intercepts, the domain. Is there a hole? If so, where? I'm gonna write those out for you. One more thing I'd like to add on. I'd like you to make an XY chart. If I were you, I'd put the hole on there, because it's a point, but I might write hole after it. And then find me 3 things, 3 points that you could use in graphing this thing. Because you know you'd graph the asymptotes first. But then you'd need some more points to be able to finish the deal. All right. Pausing again. The word is in Notability. It's the add button, and then stickies, and grid. And you can add in a little piece of graph paper. Okay, let's see how you did. I hope you noticed that it would factor. right? So the bottom part would factor into x plus 7 and x minus 3. And then this creates the whole. So I'm going to cross it off and show what's left. I got 2x on top over x plus 7 on the bottom. This is called the simplified function. And I think it's handy. Why? Because it helps you find the whole. But wait, the whole is at 3. Because 3 is what makes the function crash. But it's 3 comma what? Well, you put the 3 here and here. And you get 6 over 10. 6/10 reduces to 3/5. Raise your hand if you had 3 comma 3/5. Nice, that's where the whole is. The x-intercept, finish this sentence. X-intercepts are where what? Where y equals 0. So that's what makes the top 0. What makes the top 0? Right here. 2x over x plus 7. What makes the top 0? 0. So, 0, comma, when you put in 0, you get 0, 0, 0. Okay. Did I do that right? All right. So, 0, 0 is the spot that is on my graph. The whole is another spot that is on my graph. So, I'm going to put 3 on this list, comma 3/5. And I'm going to put 0, 0 on my list. And the y-intercept, that'd be another spot on my graph. The y-intercept is where x equals 0. Wait a minute. The y-intercept's the same thing? Think about it. 0, 0 is the x-intercept, and it's a y-intercept. Right? Okay. Then the horizontal asymptote, is this a bob, a sob, or a bot? Hello? Same on both? Yes. If it's the same on both, it's a ratio, y equals 2. And the vertical asymptote, no wait, that was the vertical, sorry. The horizontal asymptote. The horizontals are the horizontals. I'm doing this wrong, sorry. So horizontal is the y equals, and that one was the one where it was a ratio. You always ask Bob about the horizontals, and so y equals 2. X equals what? -7. So that should go on my graph. X equals -1, 2, 3, 4, 5, 6, 7. Like that. The domain, remember, anything that crashes your function is out. So holes make it die, and so do asymptotes. Both of those are breaks in the function. So -7 is one of them. And the other thing was the hole, which was at 3. Both of those are spots that don't work. So it's everything except 7 and -3. Look, these things, for this type of question, the spots that are empty are going to be asymptotes or holes. All right. What if I just need one more point? So I know it goes through 0, 0. I know it goes through 3 comma 3/5. Somewhere in between there. Yep.
3 comma 3/5 is a hole, so it's
Oh, that's a good point. I should zoom in and make that an empty spot right there. 3 comma 3/5 is about halfway. Empty spot right there. Okay, and then wouldn't it be nice to have a couple more points? I recommend spots just on either side of the vertical asymptote. So let's put in -6 and see what we get. That would have been a smart point to pick. And then what's just on the other side of the asymptote? Come on, don't be so quiet. What's just on the other side of the asymptote? -8, good. So I'm going to put in -6 and -8. And I put in -6 here and -6 here. Is that horn driving anybody else crazy?
Yeah.
I didn't notice it until you mentioned it.
Oh,
It
great.
takes a lot.
But now it will. All right, -12 over 1, which is -12. Okay, so -6, -12. And -8. -8 goes in. And I have -16 over -1, which cancels and makes positive. Ooh, positive 16. That's a big number. Okay, so I made this one not great in that it's hard to fit on the graph. You can bet that the one we have for you will fit on the graph better. But I know it's way up here, and there's another one that's way down here. So generally speaking, this thing's gonna go like that. And from one point, it's really hard to know. I'd need a few more points over here. So I'd put in a few more negative numbers to figure out exactly where this thing goes. Okay, that's good enough for the amount of time we have. We have so many things to cover. I need to move on to the next thing. All right, next thing is the hunt for something. My mom and dad like to hunt for blueberries. My mom and dad's name were Bob and Sally. Sally was the pro. She would pick blueberries really fast. She was really good at it. And she'd come out of there with a huge bucket full of blueberries. And I thought when I got older, like, oh, I'm young and like, you know, I'll be able to outpick my mom. No, never. Never once outpicked my mom. She always picked so much more. So anyway, Sally picks blueberries. And let's say that she picks 400 blueberries in 20 minutes. And there was this one time when my mom and dad together were picking blueberries. And they got a record 800 blueberries together in 14 minutes. Set up the equation, and then this one's got pretty big numbers in it. So we're just gonna have you set it up and think about what you would do if you had to solve it. Don't actually solve it, that'd take too long. Remember, these are always a rate plus a rate equals a total rate. Pausing. So at the end, what we'll be able to figure out here is what Bob's rate of blueberry picking is. And since we've done everything in minutes, we'll say per minute. Okay, if you haven't already, compare with the kid next to you and see if they know how to set these up.
You can use any type of structure rate if you can. It doesn't matter, you just said Bob trying to do this thing.
Now, if you were wondering, like, you didn't tell us the top and the bottom. Well, if I wanted rate, then I want the rate per 1 minute. And that would have been your rate. If you had just solved for R and you hadn't put it over 1, it'd still be R. So, all right. And then remember, at this point, you'd be able to simplify it. R equals 400 divided by 20. It's like 40 divided by 2, which is 20. Sorry, plus 20 equals. And then I can cut both of these in half and say it's 400 over 7 at least. Do you get from there? It's pretty easy to clear the fraction. Question?
Why do you, oh, I see, you divide them both by 2.
Yep, just cut them both in half. All right. So, this is just a fractional number of blueberries, but the rate for Bob is 400 over 7 minus 20. And when you have a really gross answer on the test, you'll be able to write it like that because you won't have a calculator. All right, moving on. One more rate question because we got a lot of questions about that, and I'm judging the room, and I think we could use another practice. Yes? Sure, you can absolutely simplify further. But if I multiply everything by 7, the R will get a 7 also. So that's gonna make it complicated again, but you could, I just don't wanna take the time, but we could reduce that, but I don't want to. All right, I need to move on. I'm gonna do one more rate question. This one's gonna be a much smaller numbers because it's about finding diamonds. There's a place in the United States where you can go to a national park and you can look and try to find diamonds. They're literally just this like huge area where you can walk and you can find, and people have, like in different years, all of a sudden there'll be like 2 diamonds found this year, and then next year somebody finds one really big one and then a couple of small ones. And anyway, the point is you could find diamonds. So this is going to be, my mom and dad decide if we like blueberry picking, we're going to try diamond picking. So they go park their RV next to this national park, and then they go out for several weeks. And let's say that Bob is better at this, and he finds 2 diamonds in 4 weeks. We don't know Sally's rate, but later on, Sally and Bob together hunt for 2 months, which would be 8 weeks. And let's say that they find 5 diamonds. Then the question is, if Sally were to go pick for a month by herself, 4 weeks, how many in 4 weeks then? Could Sally pick by herself? All right, rate plus a rate equals a rate. If you can't read any of this, I totally understand. You can ask me to repeat that, but I'm not going to set it up. You got to set it up. And you should be able to solve this one. I made the numbers nice enough. You should be able to clear the fractions and get it down to just a nice clean. How long would it take Sally? No. How many diamonds would Sally find in 4 weeks? Pausing. Okay, so make sure that as you write out your equation, you keep your units in there at the beginning. Now for Sally, what we wanted to have was how many in 4 weeks. So, how many in 4 weeks? So 4W, and I guess this is X. Okay, I could have put D for diamond. That might have been smarter. In fact, it is smarter because I know these are diamonds on top. So I'm going to use D. And then, last but not least, together, it was 5 diamonds, 8 weeks. And I kept all my D's on the top, all my W's on the bottom. Yay, now I can simplify. 1/2 plus 1/4 D equals 5/8. Could I multiply by 8 and 4 and 2? Yeah, but it'd be a lot smarter to just multiply everything by 8. Because that'll clear all of them. Know what I mean? This is really like 4 times 2, so the 4 will cancel. And this is really like 4 times 2, so the 2 will cancel. And there's my new equation. 4 plus 2D equals 5. And you can tell how many diamonds from that. Let's just finish it. Subtract 4 from both sides. I apologize for the going up thing, but don't have room underneath. 2D equals 5 minus 4 is 1. 1/2 of a diamond on average over that amount of time. Did you guys get a half? Yeah. Okay. They don't find many diamonds, so you would question whether it's worth it. And then all of a sudden there was this one guy who found like a 4-carat diamond, which is worth like 20 grand. And he was probably only hunting for like an hour. So like it's like a lottery where every now and then somebody wins big. Okay. Here's another type of question. Draw a box. Start with a rectangle. From that rectangle, make 3 lines that are all parallel to each other, and then just connect them. We're going to call this length, width, and height. And I'm going to say, we want the volume of this box to be 100. And imagine you're designing the box and your boss says, hey, you know, I really think it'll look nice if the bottom of the box is a square. So we're going to say that the length equals the width. And then I think it would look especially nice if it was taller than it is wide. In fact, let's make it twice as tall as the width. You should be able to set that up. Now, what you always do, in my opinion, is start with the key formula: volume, length, width, height. Then try to replace this with things you know. Like, I know the volume. It's 100. It's a 100. And then try to swap this down so that you can get it down to, sometimes you can get all the way down to one variable left. There's only one. Or sometimes you get two variables. If you get it down to two variables, you'll need another equation. But then sometimes there is. Sometimes they'll say, oh, by the way, we know the perimeter of it. And then you have this other equation. Here's the key. Do you ever know this? If you have two variables, you're going to have two equations to solve it. It's called a system of equations. If you have three variables, you will need three equations to solve it. Would you agree this problem has three variables? So if I don't end up with three pieces of information, three equations I could write about it, then I can't do it. But I know one of my variables right here. That was my first piece of info. But wait a minute, there's actually four variables in it, because I have volume equals length, width, height. Okay. Well, how am I going to do this? Well, I know that length equals width, so doesn't that just cut out one of the variables right there? And it's twice as tall as the width. That means something about the height and the width you should know. All right. Talk to your partner about what you think the answer would be on this one. Okay. If length equals width, couldn't I just call this length times length? And then if the height is twice as tall as it is wide, if I wanted to write that separate, it would be height is twice as big as the smaller one, which is W. Then I could replace H with two W's. But W's are the same as L's, so I could replace H with two L's. Did you get it down to 2L to the third equals 100? All right. So if I was going to solve this, I'd divide 100 divided by 2 would be 50 equals L to the third. And then how do you solve those? Well, you wouldn't probably be able to do this in your head, but do you get, I could do the cube root. Cube root. Like that. Or put it to the power of 1/3. Power of 1/3 would have been a good answer. So I would have totally accepted that for the length. All right, one more type of question. You've got a wall on the backside of your house. You want to build a long, skinny garden up against your house because you got a lot of sun right there, and you're going to plant flowers and things that are going to go well in the bright sun that'll bounce off the back of the house. You don't need to have a fence up against the house to keep critters out, unless critters are going to crawl out of your house and into the garden, and that'd be scary. Okay, so we're going to say just a fence around the outside edges. So do you get it only has 3 sides of fence? Okay. Let's say we want it to be 4 times as long. This is going to be length, and this is going to be width. 4 times as long as wide. Already, you should be writing equations. And next, we're going to say that we've done the math on it, we need to have a 200 area. You should be able to solve that. if you're ever stumped, start with the formula that you know. Like, there's got to be a master formula. Write it all the way out with both sides. Stick things in until you got that equation down to just maybe one variable if you're lucky. If it's got two variables, you'll need a second equation to go with it. It's 4 times as long as it is wide. Okay. Now, I could ask you for the length. I could ask you for the width. Or I could ask you for the total amount of fence. Which is just kind of adding up the length and the width, but you know, it's a little more complicated than that. All right, set it up. If you don't understand it, I'll help you in a minute. But start with that master formula. Okay. I hope you thought area, length, width. And area is 200. Length, well, I can't just use length and width, otherwise I still have two variables. So this is the 4 times as long as wide. So L, and does that mean that the width would be 4 lengths? No, these do get confusing. So I'm going to say, if this is the length and this is the width, I'm going to write a second equation and make sure it's right. It's 4 times as long as it is wide. What's longer, the length or the width? Which one's longer? Look at it. Isn't the length a lot longer? So if I want to put a 4 in here, do I want to put it on the W or do I want to put it on the L? If the L is bigger, yeah, 4 times the smaller one. You got to take the smaller one, times it by 4 to get the length. All right, so that the length is 4Ws, I can put 4W here times W. There you go. Do you get how that'd be pretty easy to solve from there? If the sticking point was right here for you, then make sure you make a separate little equation like that. And remember, the bigger one doesn't need to be multiplied by something. The bigger one is already bigger. Take the smaller one and multiply it by something. Okay, last thought. This is a cylinder. A cylinder is made up of a radius here, and you'll need a height here. And does anybody remember the volume formula for a cylinder? Tedros.
Yeah, is it radius pi per 2 radius pi squared? No, radius, that's what it's got.
It's
Pi in it somewhere.
Pi
Radius.
r squared. It's got a circle in it. Times the height. There's the volume. Okay. Now what if I said the limit of the volume as r approaches infinity? I want you to think that through. And I want you to figure out what you think the answer is. Don't say it. Write down your answer. And in a moment, you're going to compare it with the kid next to you. Okay, compare. If you understand this, you'll already know. As R gets bigger and bigger and bigger, what's going to happen to the volume? Bigger, bigger, bigger. So it's infinity. Raise your hand if you had infinity. Okay, good. Now what if I say that the volume is 1,000? And now, what's the limit of the height? Focus. What's the limit of the height? Think it. Stay here for a second. As r approaches infinity, what's the height gonna do as the radius gets bigger and bigger and bigger? What's the smallest it could ever get to? The limit would be 0. All right. Remember, you got a Schoology quiz, and you should do your homework so you can compare with your other partners. Have a great day.